So today we're going to look at the average value of a function. So the average value function essentially represents the average height of that line. Okay, we want to know how high is that line and what is the average height of that line. So it's got to be somewhere between the minimum and the maximum. It's going to be somewhere in here. Okay, so I've actually drawn in blue there the average height of that graph. So that's what seems reasonable, that the average height is along that line right there. Okay. Now we can find the average value of the function f of x by looking at its area under the graph of f of x. Now it's really important to understand that we're talking about f of x, not big F or the integral. Okay, we're talking about the average value of the actual derivative function here. So what we can do is, to find the average value of a function, we can find the area underneath this curve. Okay, so the average value from A to B is going to be found by finding the area under this curve. And once we find the area under the curve, we're going to just say, well, that area we can rearrange into a rectangular shape, and the height of that rectangle should be the average height of that function, because this area is this is the area calculated under the curve, and the area of this rectangle should be base times height. Well, then the height must be the average value of the y values of that particular area. Okay, so that's the idea then. We're going to take the area underneath this curve, this f of x curve, we're going to find that area, divide it by the width of this in the interval, and we'll get the average height of that same curve. Okay? So this is a formula then for the average value of the function. We're going to take the area divided by the width, again getting the height of the rectangle. We're essentially transforming this into a rectangle, and it looks like this. The width is going to be b minus a, so it's going to be point b minus point a. That would be the width of that rectangle. And the area under that curve is just going to be the integral of f of x dx, and we will find the average value of the f of x, this derivative function here, find the average value of that function using that formula. Okay, so let's apply this then. So we're going to find the average value of the sine function between 0 and pi. So if I sketch out my sine function between 0 and pi, there it is. Okay, I want to find the average value of that function. So essentially what I'm saying is that if I calculate this area under here, okay, the area underneath that curve, and if I rearrange that area into a rectangular shape, so that's about the equivalent area under that in that box. Okay, so what I'm saying is that red area is equivalent to the yellow area. This height here, that height here, represents the average value of sine x, okay, from that in that interval. So then I'm going to apply the formula to this, which is essentially what I'm calculating. Taking the area, dividing by the width, it's going to give me the height of an equivalent rectangle. Okay, so average value is equal to 1 over the width of the interval times the it's going to be the area here from 0 to pi under the sine x function and divided by the interval pi. Okay, so I'm going to find the area by using the antiderivative. It's going to be negative cosine x from 0 to pi. So the area part of this, okay, there's my area. It's going to be from negative cosine of pi minus negative cosine of 0. It's going to be 1 over pi. That's going to be 1. Negative of negative 1, which is 1. Minus negative is plus. Cosine of 0 is 1. So there it is. The average value of that function is going to be 2 over pi. Okay, so if we take a look at this graph here, we know the max value is going to be at 1. If I actually work out the decimal value of 2 over pi, I get this is approximately 0.64, which is about right. Okay, that looks like about, yeah, it should be past halfway, and that's going to give me the average height. Okay, so this is the average value of sine x. Okay, so there it is.